Hello, guys, and welcome to another MLOps coffee session. I'm Vishnu, and joining me, as always, is Dimitrios. Hey, Dimitrios, how's it going?
What's up, everyone?
I think I see a really, really cool hoodie that you're wearing. What's that about?
You noticed. All right, so let me just quickly give the story of this. If anyone is wondering, I've been threatening to make some MLOps community merch for the past, I don't know, 6 months, seven
It's been a
months,
real
and
threat.
I finally got it out. And so this is coming to the community very soon. I just printed off some basic tester items before we can give it to everyone. I want to do some QA on it, and then it's looking good. So I'm going to give it to people. I also have this one just to shamelessly promote more of it, but this one is hilarious. Kubernetes is a gateway drug, everyone.
That's
Keep that in
beautiful.
mind. And with that in mind, we should probably get cracking on the
We really
podcast that
should.
we got scheduled today.
Yes, we should. And we have a very, very special episode this time. We have two very special guests joining us that I am very excited to hear from and to have their sort of collaboration on our podcast. First up, we have Mike Del Balso, the CEO of Tecton. You guys have seen him on our Slack, on our Mega Ops newsletter, is a huge supporter of the community and very excited to have his experience joining us on the podcast today. Thanks for joining us, Mike.
Thanks for having me. Happy to be here. Thanks.
I should also note, Mike, thank you for the sponsorship because you see where your hard-earned money is
I was
going.
going to ask. It looks cool. We got to get some of those design skills and Tecton side too. It's great.
Yeah.
And our other very special guest is Erik Bernhardsson,
Hi.
the CTO, former CTO at Better, engineering leader at Spotify, all around data celebrity. You guys have seen him on Twitter. Many of you will have seen his blog posts, and we are super excited to have you join us, Erik. Thank you so much.
It's fun to be here.
Currently working with 250,000 other people at a stealth startup, according to LinkedIn.
Is that right?
It took me a second to get that, but that makes a lot of sense. I was like, this is a big stealth startup.
Does my LinkedIn say stealth startup? Like now I'm embarrassed.
I think it does. I think the last time I checked, it was like stealth startup.
I'll have to update it. Sorry.
Erik, are you still in super stealth mode with whatever you're up to?
I mean, I'm not like actively like tweeting about what I'm building. I'm not like, trying to like keep it super confidential, but more because like it's like still I haven't found a like good way to like pitch it in like 3 lines. So,
Sure.
like kind of explaining what I'm working on takes like probably like 20 minutes right now.
Got it.
Hey,
Okay.
well.
Well, we don't want to force you to like announce it on this podcast or something like that.
Appreciate it.
Hey, are you talking at all about like what is the high level space like a little bit beyond just, I assume it's in data, but
Yeah, I mean, I think I guess the thing we're all seeing, and probably everyone who's working in data space is like a very fragmented space with a lot of widgets and a lot of different tools, and sort of a new blog post every 3 weeks about what's the new data stack, or actually every 3 minutes probably, and so I think rethinking what that data stack looks like, what are the different tools, like what are different layers, like should they integrate better, should one tool do many more things, like to me, and where do you start? To me, that's sort of, I'm answering your question with a new question, but to me, that's a sort of, the questions that I've been obsessed with for the last year or so.
one of the things that I've found, sorry, Vishnu, I didn't mean to kind of derail here, but I'll just add something in there. Is one of the
Not
things
at
that
all.
I
Go
found
ahead.
with a lot of the new modern data stack stuff is that, we keep, and this is it happens in a lot of spaces, we keep kind of breaking things into more and more layers. And then it makes, it just makes it harder for a new person to get started. And it makes it harder for a new person to understand, like, what are the pieces that I need? And like, oh, I need 10 different tools, when maybe before I would just have bought one tool. Maybe that one tool would have sucked compared to having these 10 different things working together nicely. But there's a little bit more complexity for people today. And And I've also thought about like that allows that there's some opportunity for maybe combining some of those layers to make it simpler for someone to get started. Maybe not necessarily technically building a product that crosses multiple layers, but just finding some way to group them together. So if you're just someone who's new to this, there's just a simpler story, a simpler onboarding without having to deal with like 12 different tools at first.
Yeah, totally. And I think it's like the classic saying in business, there's only two ways to make money: unbundling and bundling, right? And I think, and maybe we're starting to see some bundling. I don't know. 5chan acquired HVR last week, which to me is like first like major acquisition by one entity, buying another entity in the same data spaces. So to me, that's like, is that going to be the future? Are we going to see more consolidation? I don't know, but it's like when I see a fragmented space like this, I get excited because it means like there's a lot of customer demand, but on the supply side, it means like companies have still not like quite built what customers want. And I think that's a big gap to fill that I think is really exciting.
And that's something that certainly is, evolving on the data space, and we're even in earlier stages in the ML space as well.
Totally.
And so this is like a common theme that you'll see in the MLOps side of the world, where where there's a variety of different tools that all touch on the same thing. And they're kind of in different heading things from different angles. And, the space is so early that kind of like what the different layers are is still kind of, I think about it as like annealing, like it hasn't really settled yet. And so we're not really sure, like, and it seems like it's still not 100% settled on the data side of things, and the data side of things is significantly more mature than the ML world. So
totally, absolutely. I mean, like I look at like fintech, for instance. Like fintech is like, okay, like Stripe is the lowest layer. I get it. Like, let's move on. Like, what are the next layers? Like that, or like Adyen. I don't know, whatever. But it's like there's a sort of more maturity in like what are the layers, and I don't think we're there. I mean, maybe AWS is like one layer, but like what are all the layers above? Like no one knows. Anyway, I don't know. Like we can talk about this for hours. And maybe we should loop it back to also I don't know, Demetrius or
wait, along those lines, don't you think that the complexity makes it so much more difficult to like come to a final decision on the layer?
You mean like the complexity of
just doing data stuff?
I found, one thing that I actually wanted to bring up with Erik, which is kind of related to this, is that I've seen there's like very different kind of use cases for data. And I don't just mean like I'm building this kind of dashboard or I'm building this kind of report, but I mean, like in Tecton, we deal with a lot of like operational use cases. I'm building a production real-time pricing system. And you can think of that as like a pretty advanced data application, or like Erik, you can think of like some of this stuff that was like the recommendation stuff at Spotify, right? Like that was, you had some operational side to that, but it also depended on a lot of like analytic data that came presumably from your warehouse at some point. And then there's all these analytic only data use cases that are just like, hey, I'm doing some BI kind of stuff. I need to plot a line of best fit. I need to have a dashboard, something like that. And so I've seen two different data stacks to support those. People tend to have, be in this kind of like Hadoop refugee world, kind of like Spark heavy to support the operational stuff, and then have a variety of like very operational data systems. And then it's a lot more modern data stack, warehouse first, ELT, stuff like that on the analytics side of the use cases. First of all, do you agree with that? Do you think those things are coming together over time? Do you think they're kind of separating?
I don't actually see a lot of people using Hadoop at all these days.
Sorry, when I say Hadoop, I meant I said Hadoop refugee, and it kind of means people who are in the Spark only world, who are like, sorry, I meant to say data lake plus Databricks kind of thing.
Yeah, I think my feeling is like there's been a little bit of like a fragmentation where data warehouses is like clearly like the better thing than Hadoop for like 95% of things. And you know, and I've always been a big proponent of using SQL for as much as possible, like pushing the like filtering and the joining and the group bys down to like the engine level in SQL like makes so much more sense to me than like trying to write it in like Java or whatever.
Yeah.
I think the sort of unfortunate side of everything shifting to SQL is like there's still a lot of stuff you need code for, and that I think is like maybe been a little bit like sort of forgotten about, and you know, and that's maybe what you're talking about when you see these like Spark refugees or you know people still you know clinging on to that. It's like, yeah, of course, like there's going to be a lot of stuff you still need code for, and I think you know one question I ask is almost like, has the pendulum swung too far? Like, are we like too far into like SQL land these days? Like I love what I'm seeing, you know, with you know, especially of course like Snowflake and but also things like DBT and Materialized and other things, and but I also like feel like you know in like whenever it was like late 90s or something like that, like there was like a trend where like you know everyone was using stored procedures and triggers, and like we kind of learned the lesson of like not putting business logic in SQL. And so I don't know, maybe this is like a different thing you're talking about. Like I do think there's like a sort of an interesting like schism between like, okay, what's code and what's SQL, and like how are those things, are they the same layer? Like are they like neighbors in the same layer, or like are they like on top of each other? Like I don't know, and how's that gonna shake out? I really don't know.
Yeah, I think that's a really important distinction, and I think the needs for or how much SQL supports your use case is very different for analytics use cases versus machine learning use cases, from what I've seen, and so we have a lot of people like on Tecton platform who. Like we basically have a framework that lets you write, you know, certain transformations in SQL, but then also, you know, write data frame manipulations, and so like have some procedural code. And I don't think our customers would be able to use us if we didn't support that kind of procedural side of things. It's basically, you know, it's a framework in Python, but like if we didn't support that kind of procedural, kind of non-SQL code editing, data frame stuff. It feels like for machine learning folks that is critical for them right now. And I've seen a lot of the stuff that's like, hey, do ML in your warehouse, or you know, we'll just like ML purely in SQL kind of thing. I haven't seen that stuff really be adopted much, and I suspect that. Well, the thing that I'm not sure about yet is that because the ML and ML use cases are in their infancy so much that we don't really have a clear set of requirements that we can kind of like converge around to put into like a simplified SQL interface? Or is it that ML use cases inherently are just way more complicated and they need all of this code? They have just different requirements, and they need this code way to interact with them as well beyond just SQL.
Yeah, that sounds right. A lot of people, I think, switched over to SQL because it was so obviously a better platform to do a lot of like basic data aggregation. But I think in machine learning, it's obvious that like you can't just do everything in SQL unless you ask Bob Mullier, who thinks you can, you know, train convolutional neural networks on top of Snowflake or whatever. But like it's sort of interesting that like the machine learning practitioners stayed in that world, and like I think maybe some people are going to come back to that and like realize like, yeah, actually code's kind of nice. So I don't know. I think there's going to be,
and also Snowflake is, you know, they're building Snowpark, which is their kind of like data frame API, and they already have it, I think, in private preview for Scala, and I think they have a lot more plans there. And so, you know, from that perspective, they're coming from the SQL only world, and they're moving more towards, hey, let's support data frame APIs. So they see something there, and I suspect that that's largely to help better support the data science community.
Yep.
So now you guys, all you listeners, know what it's like to actually have two experts going back and forth at it, not people like me and Demetrios who are kind of, you know, faking it till we make it. You know?
Bullshitting our way through it.
just trying to survive every hour. No, but this is great. And I think what really stands out to me in listening to both of your discussion about the state of the data stack, the different trends that are going on in organizations in terms of thinking about how to use data most effectively, is both of your high level understanding of how the challenges organizations face in doing that currently. It seems, Erik, with your experience at Better, where you were the CTO, Mike, with your experience at Uber and now at Tecton. And I really, really, want us to tap into that, talk a little bit about your experiences building platforms, having to make these decisions, and what kind of lessons you've learned through that process. Now, with that big picture sort of thought there, the first question I really want to ask is, what does it mean to have a platform strategy at a company? Both of you guys have had experiences, written blog posts, maybe even have run companies that, claim to have built platforms for others. But internal to a company, something that we talk a lot about in the MLOps community is, what does it mean to have an ML platform, et cetera? What does that title mean? What are the different titles associated with it? And it could be a data platform, it could be an ML platform, whatever. I'm going to kick it first to Erik. Erik, what does it mean to have a platform? And what kinds of things should be included in a platform?
It's a good question. I always like when people talk about platforms, I always think about the Bill Gates quote, whatever you're saying, a platform is when the economic value of everybody that uses this exceeds the value of the company that creates it. I just had to Google it because I didn't remember it. But to me, that's I don't know. To me, it's at some point in a company, it's large enough that it's worth to build internal tools because you're making enough people faster that it pays for itself, right? There's scalability advantages in making other people, not building business value directly, but building tools that make other people around you more effective, right? So to me, that's why do you even build a platform? To me, that's it's just a straight, it's hard to know, but that's the sort of theoretical, the math behind it. Now, I don't know what that means in terms of for a particular company. I think this is just so dependent on what you're trying to do. I tend to be a big believer in self-service, for instance. I tend to think, at a company, you can get rid of so many basic use cases if you just open up SQL access to a lot of people, and also create a culture of transparency and a culture of we're not trying to hide anything. If you want to query it, here it is. And you can also create this thing where sometimes people start then use it for various things, and then the data team can then go and realize actually we should probably automate this for you because it's much better. I don't know, it's hard for me to say what's the generic layers of a data strategy or machine learning platform or whatever, but I think these are sort of evolutions that everyone's going through as the company grows. And I think that's so important to keep in mind is it's really a function of how large the company is. The larger a company gets, the more, platforms you can have, and platforms supporting other platforms. And then, at some point you're at Google, and no one at Google is designing the search results. Everyone at Google is building some internal service that powers some internal service that then delivers search results, right?
I got a question for you, Erik. So one of the, one reaction that I had was, I just wanted to maybe clarify that for me, you said basically at some point it becomes, it makes sense within an organization to start building some of this stuff on your own internally in a centralized way. And I think, for me, one of the things that I like to do is kind of just decouple the build versus buy from the centralization and not centralization, and not centralized. And so, because there's people who buy platforms, and so I think one of the questions that we certainly see our customers ask is should I centralize this or not? And then obviously, and then do I build and buy? So I don't know if there's, again, also it may not be a single one, correct answer, but I think of that as a useful framework. But then another reaction to what you said, I found this very interesting, that it seemed like you, and I would agree with this, it seemed like you are implying an approach to the kind of your platform strategy. You kind of described this, not doing a lot, but kind of seeing what people are trying to do and then looking for opportunities to automate those things in a centralized way. So you're not coming with a heavy platform and maybe overbuilding or building stuff that people don't need, but are focused on providing a minimal substrate that is an enabling substrate, and then as you observe what kind of behavior is, what kind of usage happens on top of your platform, then you can begin to kind of like take on some of those repeated use cases and see what additional levels of value you can add in the platform. Does that, first of all, do you feel like I'm fairly describing that? I'm summarizing that well?
Yeah, I think your first point is fair, right? Like, I think I answered the question more from the question like, when do you build a platform team, which I think is maybe different from like when you bring in external platforms or when you build internal platforms, and because that might be a very different question depending on if there's something you can buy. Like, of course you should buy it, right? The other question, yeah, absolutely, I 100% agree. Right? Like, I think there's so much value in like sometimes giving people like simple tools and seeing what they use it for, and then like based on that, you almost have to have like an internal, and that goes back to maybe like building platform teams. Like, you have like an internal data team that like, discovers what people are actually using, and then like helping them actually like, build it in the right way. I've seen that work really well. We're like, internal platform teams end up doing a little bit of like platform engineering, but also a little bit of like consulting and embedding into other teams.
Yeah, and that's very similar to, so we had that same approach when we were building Michelangelo at Uber. It was like, we built the most basic thing, and then we were just helping people build these ML applications on top of it. And every time, we would see we would end up doing a lot of like this bespoke work. We would repeat that bespoke work, and then it would become obvious. Okay, that's the thing we should add to the platform, and that's pretty. Seems like a pretty like low risk kind of obvious way to approach it. One thing that I've been seeing in the machine learning platform world, and I'm curious if you see this in the data world also, is there's a lot of sometimes we see like a team spin up as like the ML platform team, and they're kind of running ahead of their use cases. They're like, hey, we know we need these 50 models in production by the end of next year. And so we're building the stack to enable these models to be built, stuff like that. And when I hear that, I kind of think like, well, you probably want to be doing this with the use case team because you don't really know their requirements, and you have a big risk of like building a bunch of infrastructure or building a whole platform that at the end of the day is not going to support their needs if you weren't super clear on their requirements. Or, maybe you think that that's an important use case now, but when it comes down to it, it's not important enough, and that team gets reorged or shut down, or the people don't have the budget to support, to like use your platform or whatever it is. Do you see anything like that in the like non-ML data world? Because it seems like I see that again and again in the ML world.
Yeah, I see it all over, and I struggle with this a lot too. And I think to me, my conclusion has been like, you don't want to go too far either in terms of decentralization or centralization, right? Like, and I think that applies both to data and machine learning. And I've led machine learning teams that arguably were too centralized back at Spotify. This was like 5-10 years ago, but also data teams like thinking a lot about how do you organize that. And the problem is like basically like you can end up like doing everything like completely centralized, like what you said, and like build all these like crazy like internal like prototypes or whatever, and then trying to like go out and like kind of like shove it down people's, like impose it on people and say, hey, like we built this thing, like you should use this. And then these other teams, like they're going to have their own like conflicting goals and roadmaps. And, they might not care at all that you built this like amazing prototype, because, that's not really like the metric they care about this month. Right. So on the other hand, like some people go completely decentralized. And I think that's probably more common on the data side. Like, every team starts hiring their own like, data analysts or business intelligence specialists or whatever. And you end up having this like, people all across the entire organization writing SQL and starting to write scripts and doing data work. And what I think you end up losing then is like, you don't really have like, I mean, first of all, like hiring standards are going to be like completely inconsistent. There's not going to be like a sort of a, organizational like oversight. People are not going to report to managers who actually know what they're doing. And so I've sort of come to realize like the only way to really solve this is to have some sort of a hybrid thing where you have centralized reporting, but decentralized backlog management. So what that means is like you have like a centralized data team that reports into head of data, but then those people are then like embedded into other teams and working day to day on like whatever those teams think is important that day. And I imagine it's something similar, like probably works reasonably well for machine learning too.
Yeah, we
I'm curious to
iterated.
hear your thoughts on that. At Uber must have been a big problem too.
Yeah, we iterated on that model quite a bit at Uber, and I've seen a couple of companies do something similar. And one mistake I think that we made was that we tried to have people who were almost like, we call them the applied machine learning team, and it was like the folks who were ML experts, whatever you want to call them, like good people who are good at data science and good at engineering. But we, as the central team, would put them on loan to a use case team and have them build out that use case. And so that's all great. And so then the idea was great. And then we would, learn from that experience, and we would be able to kind of bring some of those learnings to the central platform team and also deliver some value to the individual use case. The challenge that we faced was a matter of almost like qualifying which use cases we wanted to focus on. And over time, we learned which use cases were the good ones and which ones were not really good for this type of model. And the ones that weren't good for this type of model were ones that we didn't really have almost like a succession plan for afterwards, like an ownership plan for who will take this thing over longer term. There's only, say, 5 people who are part of this kind of like special SWAT team group that can work on a use case team, but they're kind of part of the platform team. When they're done their project, when they get that project up and running, they want to hand it off to that use case team for them to continue owning it. And so we over time developed a whole set of criteria. Is that team capable of taking over? Do they have the right people who will know how to operate this? Do they have is this an important enough use case for them that they actually care enough? This is not just like, oh, well, this is a free resource, we'll just try it because it's kind of free for us and we'll see what we get. It's something that's like a central and important thing for that use case. And those are like, these are kinds of, I guess, like kind of reflecting the types of things that are not as obvious to ahead of time if you're like building a platform team, that like you may not recognize that these are kind of like potholes that you can step in. And so we found that to be like a pretty useful kind of like guiding set of principles after the fact. And I'm sure that's still in use today, even at Uber.
Well,
so
I'm wondering about these manifestations. I mean, I think, Erik, you put it perfectly on trying to walk the middle line or like the middle way and not go too far into one decentralization or centralization. And what are some manifestations of being too far in one camp? And how do you know? Like if I'm there, but I can't see the forest and the trees, right? Or what's that saying? The trees from the forest?
the forest.
So can't see the forest for all the trees.
Exactly.
I think if you have extreme decentralization, you have, people at like very inconsistent levels, skills and levels, and like barely talking to each other, primarily like trying to satisfy their like business partners, and not developing further skill sets and tools, and maybe also creating a little bit of a tragedy of the common problem where like people are not contributing back to that the centralized platform, right? Like whatever that is. I think if you go the other extreme, like fully centralization, what you end up having is like disgruntled business people instead, who are like, we never get any resources from the data team. Like, we don't know what you're doing. Like, we keep asking for all these things. I really just want to hire my own people. Can I just hire my own people? Because I never get any help from the data team. And that's also like a really, really bad thing. So those are the two things I've seen in either of those extremes.
The way I've thought about it is, like if you're too far on the decentralized domain, just kind of conceptually, like everybody's stuck at their own local maximum, and but if you over centralize, then you kind of are limiting or constraining every use case to what the capability needs are of the lowest common denominator. And so like everyone has to use the same platform, and that may be constraining them to some inflexibility of the one platform for the company. That could be painful.
Do you feel like it's better? Do you feel like it's better to err to one side or the other?
Personally, I think erring to decentralization is what I've found to be successful, because that allows for more specialization, and it allows for you to run more experiments in parallel, so you can learn more quickly as an organization, and you get more ideas for what to bring back into the central platform. So that's something that's nice.
I would agree with that. I think decentralization has a lot of problems, but I would rather go decentralized than centralized.
One, I guess, like other kind of dimension to all of this is in a lot of, so there's companies that are like, hey, we're starting a new company, right? It's a new company and let's build the platform team, and it's a greenfield and everything's starting from scratch. And then there's, but obviously a lot of instances where it's like, there's been many different efforts in the past at various platform efforts that have all failed, and now we're really starting the platform team, and we just hired this new person who's gonna,
Oh my God,
this
how
director,
many times? Yeah.
and it's probably like, every company has something like that.
Yeah.
And one thing that I haven't reflected on as much, but I think it's like an interesting topic maybe to dive into, is just like, what is the difference in like an optimal platform strategy across those two scenarios, right? If you are like in a totally greenfield platform and like the use cases don't have a ton of legacy, they're just kind of all just starting at the same time, versus you imagine you're at some existing big company, there's been use cases in production for years, they're all on various versions of legacy systems.
It's always a bank,
and you're trying to centralize. Like when we talk to, the bank is like the obvious kind of example, but it exists even in like much faster moving organizations that have been around for years. So
I think a related question, I don't have a good answer to that one, but a related question I've been struggling with a lot is also like, what is the goal of the platform team? And how do you measure it? And maybe this is counterintuitive or not, but like what I've sort of realized is almost like I kind of want to measure like NPS of platform teams, like, because like I've seen platform teams really mess up when, like building the right technology, but never getting other people to use it because it like they don't really care about like people actually using it or whatever. And so I've sort of come to realize like you really have to have a service mentality in the platform team, and you almost have to have like other teams like rate them and say, do we get value from the platforms? Like, does it make us happy? Like, like are the platform teams listening to our concerns?
Yeah, and also how do you fund? Like, what is the size? How big should the platform team be for an organization? Right. That was the thing that we were actually at the beginning of at Uber, there wasn't like as much of a being careful about budget and stuff, but it became an important topic later, and it was like, what is the right size for this team? And so we spent a bunch of time trying to come up with these metrics that describe one, the NPS like you're describing, and then secondly, like what scale of value does this team help support? And that was an immensely challenging, actually this is kind of interesting because that was an immensely challenging thing for machine learning, but machine learning is I think it's much closer to some of this like end usage of the data. It's kind of like after you've done all the data modeling, then you might make a prediction. And for example, for us, like it helped power surge pricing. And so we can kind of come up with a value of surge pricing. But in like more like generic data platforms, you may be still doing extremely critical stuff, but you may be farther from some of the end consumption or the end usage or application of that data. And it may be harder to kind of like appraise the value of that platform from the end usage of it. Have you found a way to like think about what is the value of a platform, or how to size it appropriately?
No, but I think to me, like what I think is critical to like making a data strategy work or like making a data team successful is to have very strong support in the executive team and like the CEO in particular for like trying to solve things in a data-driven way. And like if that's like the philosophy that you're going into things with, like the rest sort of falls from that. Like if everyone's bought into like this like culture of like, oh, we launched this feature, are we going to celebrate the fact that we launched a feature, or are we going to celebrate like whatever metric we improved? Like it's like a big cultural shift. But I think as soon as you get people to like think more about, okay, what are the actual like business impact of what's the business impact of the features we're building and the things we're focusing on and the metrics, like then you kind of have to have a data team. Like it sort of follows kind of naturally. I think. I don't know.
But you do need so there certainly is the like focus on outcome, like you're describing, right? Like we don't care if we did this work, it matters more about the impact. But before you have that impact, there's also you kind of need buy-in, as you said, from the executive level to like embark on this journey. And at some level, that's a little bit of like a vision kind of exercise of like, do we think we want to be this kind of organization? Let's paint a picture of what we could achieve. And you need someone to basically take like an internal venture bet on this kind of thing to say, let's invest in this. And maybe it's a little bit more still in the speculative stage for machine learning teams. Because I think like maybe less of a kind of seem like less of a risky investment on a core data platform. But you still need someone to like take that first investment to like, let's spin up this team, let's go out on a limb here and make this happen before we see that outcome.
Right. And, this is a great segue, this entire discussion, into the original reason that Demetrius and I wanted to make this conversation happen, which is this great blog post that you wrote, Erik, called Building a Data Team at a Mid-Stage Startup, a Short Story. I think a lot of people in our community read it. It was one of our most active threads, probably of last quarter, in terms of just talking about how, number one, how well written the story was. You really nailed all the characters and got the whole flow there going. I was reading it like a page turner. But also just how relatable it felt. Many people had faced similar situations. And so first off, I guess just to kind of ask, how did you get the idea to write this? Like what made you want to put this entire sentiment into this beautiful blog post?
Yeah, I started thinking about, how to, I remember I always had a blog and like I read like dumb stuff there all the time. And so sometimes people read it or sometimes not. But like one of the things I always wanted to write about was like, my sort of lessons running different data teams. And then, at some point I realized it's actually easier to write it as a story. So, because initially I started writing it as like, just like, here's how you do it. Like, I think this is important. I don't think this is important. And it just like, was like very dry and boring. And I was like, actually, let me just write a story instead. It'd be more fun. And then it was like, actually it started out as like 3 times as long and I had to edit it down because it was like so much stuff like that was just like, it would be too long to read. So that's sort of the genesis of that blog post.
When I read that, I posted on the MLOps community and I was like, I've lived through this exact story, but for ML stuff. And I had, in my mind, as I was reading it, I was like, oh, I've seen that in the ML world. And then I asked the team, or asked the community, like, what are some of the kind of like little kind of vignettes, the kind of like little mini scenes that you have experienced in the ML side of things? And some of the ones that came up were, well, one that happened to me personally was just like the executive who thinks you need like the most powerful possible thing. Like, we can't use your platform unless it supports unsupervised real-time reinforcement, online reinforcement learning or something like that. And you're just like, I don't even know if that's a thing in the first place. So do you really know what you're talking about? Or like the team that's building the team that's like a single use case team that's like, oh, now we're the platform team and we support the whole company. And then you have 2 platform teams and you're trying to like figure out like how to handle that internally in a company. There's a lot of those little things that I found are like very parallel between the data team, the data story, and the ML platform. So I found it very fascinating.
I'd love to ask you a question, Mike, like having this conversation, thinking through about like differences between data and machine learning. And I have a lot of thoughts on this, but I'm curious to hear your thoughts on this. Like, why do we need a separate machine learning stack? Like, is it machine learning a sub-problem of data? Like, I'm curious to hear your take on like, what is there like, a fundamental difference where we need a separate stack, or is it kind of the same? Is it like 90% this?
I think it's mostly the same. Some of the workflows are just different, and so
And what are those? And I'd love to hear your thoughts on like, because obviously you're working on feature store, so like maybe that's like one.
Yeah. So so like some of the stuff that we So I guess like one thing to mention is just like, I really am not a fan of having like a completely separate ML stack that's divorced from the like the main data platform or the main data stack, because there's not really or it's kind of counterintuitive, and end up building like the same thing twice. The reason that I think we see that often is that either the data platform is not treating ML use cases as something that they want to support. Oh, that's one. That's A. B can be that ML teams just suck at working with stuff that already exists, and a lot of folks in the ML world just really want to build their own thing, and they're, for them to be able to put something into production, they have to have the skills for them to be at the role and be successful at the role that they're in already. They just may have had to be the kind of person who can kind of get stuff working on their own and somewhat independent of existing systems to put stuff into production. And that's also an anti-pattern. And and so like what we are aiming for is, how do we like make the right data science and operational? We focus specifically on like operational machine learning use cases, which is, stuff that affects the production user experience. How do we make it really easy to build those types of systems on top of an existing data stack, on top of your existing cloud data platform? So for example, we'll plug into like your Databricks or your Snowflake or something like that, and provide pretty straightforward APIs for interacting with those systems to, similar to like a DBT, save, SQL transformations or data frame transformations, which is not exactly what DBT does, and then have the right consumption use case, the right consumption interfaces for model training and for model serving. And so, there's not like in the same way you can imagine, like, you could do this stuff anyways. You could also have like a set of, you could have a bunch of like SQL macros and, instead of DBT or something like that. But the thing that we're going for is making a really nice workflow that's very intuitive and much more productive for someone building a machine learning system, like an operational ML system, and for them to then operate it safely in production. And a really important detail there is having that guarantee of data consistency between model serving and model training, which is something that can be tricky for a lot of people.
I feel like, and correct me if I'm wrong, like maybe I was a little mischaracterizing what you just said, but like maybe to me the keyword here is like operational. Like like when I look at like machine learning use cases, they tend to actually like, in many cases, like actually power a real like, live product that's like facing consumers. And like as soon as you start building those things, you have to think about like, deployments and monitoring and logging and like, and all those things that like, maybe when you're in the data land, like you don't really think about as much, because like you tend to be, more like building, offline stuff, like analyzing things, or, at most building like cron jobs or things like that, but not really something like at low latency powering, like, real-time user features. Is that like one sort of?
That's exactly it. And when and we actually use the word operational ML very intentionally to demarcate the use cases that we focus on from like hey, I'm just like once a week running this SQL query that's going to produce some churn scores or something. Like that's not really related to, those use cases are not really like what we focus on. And so we think about like bridging, this is part of our goal, is to bridge like workflows in the data stack, the modern data stack, with kind of like the production engineering workflows. And so a lot of the engineering that we put into our platform is exactly what you said: production monitoring, like serving at scale, and SLAs related to that, and support. So to enable someone who's a data scientist or a data engineer to really easily work in the data workflow world and be able to say, hey, this is the feature I need, very simply, but then have that be available as like a production reliable data product, essentially, that you can have your production pricing system, your production fraud detection system depend on, and have a lot of the operational complexity of that handled for you. Does that make sense?
I think that makes a lot of sense. And the way I think about it is almost like, maybe this is a little bit different, but like I almost like think that the core thing that sort of makes everything hard in infrastructure land is like latency. Like when you need to do things in like low latency, like less than a few milliseconds, it actually turns out to be like a very different problem than if you need to do something with like a few seconds or a few minutes or a few hours latency, right? And what I think is like impressive with what you're building, in a sense, you're kind of bridging those like things, like you're trying to bridge those world in a way. Whereas like I think traditionally like data tends to be on one side of the fence, and like the software engineering tends to be on the other side of the fence.
Yeah, and we're not doing it by like we don't want to we're not like claiming some magic that's not there, right? Like we're not trying to say, hey, we are running every possible, like we're this magic data system that runs every possible data flow instantly or something like that. But it's more about managing the operational concerns of like some features you will want to pre-compute and they will take time and you'll pre-compute them in batch, but you want to retrieve, for your use case, you need to consume them in real time in production. Some features you compute in real time in production. For example, if you're extracting a feature from like a search query or something, like you can't pre-compute those features. You need to deal with that data in real time, and you need to bring those things together also into to feed that into a model all in real time to make that prediction. And so there's just like a lot of this kind of operational stuff that when we talk to different teams who are putting these ML systems into production, they have like whole teams of engineers that are just like trying to they're reinventing new ways to do this again and again. And so for us, it's this whole domain of like bespoke engineering that isn't really talked about much. But, we all know, we've all like, very common now to say like, hey, 80% of the, work of doing ML is data stuff. And really like the operationalization is a thing that it doesn't, you don't really like you don't really understand how challenging some of these and how much like of a rabbit hole a lot of these challenges can be until you end up like having a team of 5 people working full time on it. So
yeah,
it's one of these things that I'm sure you guys saw that at like Spotify doing the recommendations.
Yeah, no, totally. Like I've been through this and seen this very clearly. Like in many cases, I find it quite easy to train a machine learning. Like it's quite easy to like write some SQL that generates a bunch of complicated features and training that model offline. It's actually, in my opinion, quite easy to deploy that model too.
Yeah.
What ends up being hard is like, how do you generate the features in real time and keep them updated? Like that to me has always been like the real problem of productionizing machine learning models. Is like inevitably like some of the features you want are going to be very hard to pre-compute or to keep to update in real time, and that's usually where all the operational complexity comes in my experience.
Did you guys have any features that were any like real-time data flows at Spotify? So like
we faked everything.
Okay.
I mean, like we built this like 6 years ago, so I'm sure now like it's probably more real time. But like when I worked on it, like the music recommendations at Spotify, we had a gigantic set of cron jobs. I built this thing called Luigi, which was like one of the first workflow schedulers for this purpose. But that basically ran everything every night. We're talking like trillions of music recommendations, probably like some crazy number, and then we ingested that in a Cassandra cluster and recomputed only for the users that had streamed at least one track the day before. And I mean, the truth is like people's music taste does not drift that much from one day to another, so it's like kind of fine. But yeah, there was all these problems with like the cold start problem. How do you deal with new tracks? How do you deal with new users? Like and I don't know, maybe they solved it now. Like I'm sure they have, but yeah, that was in Spotify, like we could make these shortcuts because like we picked a problem where like the features don't drift that much, but in many cases you can't, right? Like if you're building an onboarding flow and you want to personalize it, like how do you do that? That's very hard.
Yeah, one thing I think is very interesting about this space is that there are as you kind of like change your use case slightly, there may be dramatic changes in technical requirements under the hood. Like if you just wanted to add, imagine you wanted to use the user's real-time context, like that's a whole real-time data flow thing you need to support, or some and then for supporting those real-time features, then what do you do? How do you generate a training data set from them later? You have to log them and manage them in a way that you can like retrieve them historically accurately for a training data set. It's
that's sort of the time travel. Like that's like my mind explodes every time I think about that. It's so hard.
Yeah, so like that's a thing that it's like one of the main things that we think about. And so it's a lot of like tricky stuff to do. We're just trying to hide that complexity and enable that all in the modern data stack. So like if your company uses Snowflake and dbt and that whole set of tooling, and then you're tasked with building a production fraud detection system, how should you do it? Are you going to build a whole separate data stack just to support that? Or like, how do you want to build that using your existing, the company's central data flows? And so that's what we're trying to enable.
But do you think we're going to end up with like a data stack, a machine learning stack, and a backend stack? Or like how much is going to be like reused across those three?
I kind of see the machine learning stack as something that sits on top of the data stack. So it doesn't have to be like a separate, I don't know, my visual, like it doesn't exist as a separate pillar. It's kind of something that's just like consumers of data. It lives up here, right? And of course, there's going to be like some ML stack, like there's going to be tools that people use to serve their model and train their models and stuff like that, and like manage the features. But that kind of lives, ideally, it fits nicely on top of what the dominant kind of data stack is of the day, presumably the modern data stack. The challenge and part of the reason why it's so complex today is that so much of operational ML is built not on the modern data stack today, that all of the ML tooling is kind of like not really designed to fit in nicely with the modern data stack, which has been largely focused on supporting analytic flows. And so there's this little bit of like convergence that I think needs to happen in industry as we see the modern data stack shift towards supporting operational use cases a little bit more. And of course, as all the operational folks who have been building like their own bespoke tooling are kind of getting pressure to like, hey, why don't you use the central system that we invested a bunch of money in? That I think that will converge, and then that interface will have to become a little bit more compatible. So the ML stack will fit in much more nicely with the modern data stack. And so we're just designing for that from the beginning.
Yeah. And my hope is also like, as you know, hopefully as we get there, we'll also see a little bit of convergence between actually data and backend. Like I think, you know, making it easier to like run jobs, like making it easier to like productionize, you know, cron jobs or whatever. Like there's a lot of things just like on the sort of core layer of like running code and like productionizing things and like different environments and containers and images. Like I would also love to see convergence like on that layer.
And we're trying to hide a lot of that from the user, or like automate that. So we're building for the user who like doesn't want to manage containers, right? So
no one wants to manage containers.
You know,
like, that's the problem. It's like kind of my point. Is like I want something that like, you know, solves those problems like once and for all the different use cases, right? Like, and I think, you know, we'll probably see more and more of that, because I think it's like so crazy these days when I look at like both data teams, but in particular like backend teams, spending so much time like wrangling with Kubernetes and Docker and, you know, Terraform, and like it's kind of insane to me.
But and I think like for the in the journey to like find the solution to this, it's very important to choose to like bite off something you can, like a chunk of the problem that you can really chew and deal with, right? And so, you know, at Tecton, we're not building a whole end-to-end ML platform. We're just focused on just almost like just the data side of the ML problem. So we're not training models. We're not dealing with all of that kind of stuff. We're not serving models. We're just dealing with the feature data flows and a couple other data flows. So that's something that we feel like we can like really deliver on. And then we'll expand from there. But I guess that comes back to, maybe to like wrap up, it comes back a little bit nicely to, you know, your point about platforms of like, start with something that you think you can deliver like a really solid experience on that people can build with. And then as you see additional use cases being kind of built on there, and you see repeatability across those, then you can expand to add a next layer of value. And so that's the approach we've taken, and it's been pretty fun so far. It's been working pretty well.
It's kind of the AWS strategy, I think. You know,
well, I don't want to compare us to AWS, but
yeah,
but it's yeah. I mean, it's been a useful way to approach the problem for sure.
Yeah.
Well, I got a lot of work done while you two interviewed each other. That was a lot of fun listening in on this conversation.
You were like eating ice cream or something.
Yeah, I was eating ice cream and popcorn, you know, caramel corn. I was enjoying the show. It was brilliant to hear you guys talk and just bounce these ideas off of each other. It was so fast paced too. I love it. Thank you.
Thanks for hosting this. I enjoyed it.
Thanks a lot. It was fun.
Anytime you guys want to come on here and just school the rest of us, you're always welcome.
Tomorrow?
Vishnu, you got any closing thoughts?
Yeah, I mean, you know, it's always, this is a topic where, you know, I think nobody's really an expert, right? There's a lot that's going on. There's a lot of different, you know, ways to look at the problem, and there's so much context to every situation, as Erik said. But we're very fortunate to have probably asymptotically two of the people that are closest to being one. So thank you guys for joining us. I think I learned a lot about what, how to think about platforms, how to think about the modern data stack and what it enables, how it should enable machine learning teams going forward. And just philosophically, kind of how to think about sort of technology development in the context of more data intensive systems that, kind of what companies and products require nowadays. So thank you guys so much for joining us. This was a blast.
Yeah, thank you. And good to meet you, Erik. It was a good chat.
Yeah, it's great meeting you.
Chat again. All right. Cheers, guys. Have a good one.
See y'all later.
Yeah.
Bye.